Alright guys, today in geometry we will be doing 7.3, which is similar triangles. If you remember from 7.2, that's when we did similar polygons. So here are those characteristics we talked about. Obviously a triangle is a polygon, so you will see a lot of similarities between last lesson and this lesson with just a couple of additional tweaks because we will only be dealing with triangles. So the first thing I want to point out is some information right here in this box. It says 3 quick ways to identify similar triangles. So you guys are going to get really familiar with these. We've got the AA similarity theorem, which basically you will just have 2 angles in one triangle and 2 angles in another triangle that are congruent. So there's one way that you can easily identify that similar triangle. The second one is side, side, side similarity theorem. So you will see corresponding side lengths on all 3 sides of your triangle, and those side lengths will be proportional. And then your third one is the side angle side similarity theorem. So basically in both of your triangles you will have 2 side lengths and an angle in between those 2 side lengths. So those are our 3 ways to identify similar triangles. Here on the front of your practice we're going to do about 1 problem or so of each, giving you guys some practice on how to identify those specific triangles as well. Alright, so it says determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So determining, we might have to do some work with the sides. If we need to figure out if they have the same scale factor, we might have to look at their angles. So that's kind of our first step, is that determining step. Our second step will be writing the similarity statement if they are similar, and then the explaining the reasoning will be one of our theorems that we just touched on real quick. So number 1, if I look at my 2 triangles, it looks like I've got 3 sides that are represented for each of them. So assuming this will be similar, I'd be dealing with the side, side, side. Now again, we'll have to check and see if it is actually similar or not. So looks like I've got 3 different lengths, a short and kind of the middle and a long for both of my triangles. So let's just set up a proportionality statement and see if they are similar or not. So we've got side 6 and 9 are my short sides, 8 and 12 are kind of in the middle, and then 10 and 15 are the long sides. And if I reduce all 3 of those, I get 2/3, 2/3, and 2/3. So that's my determining that the triangles are similar. They all have the same proportional sides, so they are similar. So my similarity statement for this, remember you can start wherever you want on the triangle, just as long as you go in the same order for both of them. So we've got triangle, I'm going to say ABC is similar to triangle DEF. So there's your similarity statement. And then our reasoning, like I said, if this was similar, we've got all 3 sides represented, so that would be the side, side, side similarity theorem. So that's all you have to do on these. Just kind of have to look and see what they give you. That way you can determine if it is or is not similar prior to doing your other parts of the problem. Let's go on to number 2. So for number 2, it looks like I've got 2 sides and an angle represented in each of those triangles, and I do have a side angle side similarity theorem that I might be able to use as my reasoning here once I do some double checking to see if they're similar. Well, obviously my angles are congruent, so we're good to go there. We do need to double check the sides. So it looks like I've got a short and a long in both of them. So setting up my proportion, 3 matches up to 4, 6 matches up to 8, and 6/8 does reduce to 3/4. So there is my check that they are similar. My similarity statement, again, kind of can start wherever I'd like. I'm going to call it triangle MNP, and that is similar to triangle QRS. And then again, we've got a side, angle, side, so that is our reason for them being similar. So a couple different examples there. If we go on to 3, now this one only has 2 angles represented in the picture. We've got A and D that have the same congruent marking, and then B and E that have the same congruent marking. Well, we know angles have to be congruent, and we do have a reasoning that only deals with 2 angles. So for a problem like this, where we don't have any sides that we have to work with or determine if they're proportional or not, we don't actually have to do any work on this. We can just see, represented by the picture, that yes, these angles are congruent. We have 2 of them, so we can go ahead and do our similarity statement right away. I'm just going to use angle ABC is similar to triangle DEF. So there's my similarity statement, and because we only have 2 angles, it is the angle-angle similarity theorem. So there's kind of one example of each, pretty straightforward, nothing too complicated about any of those. I also want to look at a couple of examples that maybe aren't quite as nice or have some tricks to them to make sure that you are good to go on those as well. So number 4, we notice our triangles are not in the same orientation, so we do have to be careful when we determine the different sides. So it looks like we've got our short side and a long side. So before we go on and look at what their reasoning would be, we need to check and see if they're similar. So it looks like I've got a 20 and an 18 for my 2 shorter sides, and then I've got a 36 and a 24 for the longer. Now when I reduce these, I get 10 over 9 and 3 over 2. So as soon as I get to that point, I know that these triangles are not similar because they don't have proportional sides. So I don't have to go any further on a similarity statement or a reasoning because they're not similar. I just simply need to put not similar for a problem like this. And this is why it's very important that you do double check all those sides. Even though they look like they could be, we need to have the proof with the side numbers. Okay? So there's an example of something that would not be similar since they did not have proportional sides. Okay, and then when we go on to number 5, now number 5 is actually a little bit trickier because there's nothing drawn into this picture. And we're going to have to draw something in order to decide if it's similar or not. Well, you can't just pick a number to throw onto a side. We don't have that option. So we kind of have to look at the angles. Now we have to think back to first semester when we learned about parallel lines being cut by a transversal. I know, it's been a while. Remember, we said parallel lines cut by a transversal create angles that are congruent. They might be corresponding, alternate interior, alternate exterior. Well, in this case, our parallel lines cut by a transversal are creating corresponding angles that are congruent. So I can draw into my picture that R is congruent to F and U is congruent to L. So that one was a little bit tricky. We had to really think back for that one. But this problem is now very similar to 3, that I have my angles drawn in. I can see that I have my congruent angles that are the same because this top part is my small triangle and then the whole thing is my big triangle, so I have those congruent markings in the right place. So I don't have to show any additional work. My work was just drawing in my angle markings. So for my similarity statement, I'm just going to say triangle. I'm going to say RTU, which would be my big triangle. RTU is similar to triangle, and now we need my small triangle, STL. So there's your similarity statement, and again, just like with 3, since we only have angles represented, no sides, it'll be the angle similarity theorem. So that kind of gives you a little bit of everything, one example of everything, a couple of things that may be a little trickier. So I'm going to have you pause the video and go ahead and try 6 on your own, and then you can come back and see how you did. Alright, so hopefully on number 6 you did get proportional sides. So for our similarity statement, we could say that KDJ is similar to triangle RPZ because of the side angle side similarity theorem, because we have 2 sides with that angle in between. Okay, so that kind of gets us used to the different types of theorems that we might see when dealing with triangles. So now when we flip over onto the back, it specifically says that these triangles are similar. So we're not having to decide which theorem is being represented necessarily, because they are similar, but it does want us to identify the similar triangles by writing the similarity statement and then find each measure. So whatever is missing, we need to find, whether it's a side or whatever the case is. So again, you guys should be getting pretty good at similarity statements at this point. So I'm just going to look at my pictures. Looks like I've got a congruent angle here, a 90, and then a couple of sides. Now, I actually have an extra piece of information in this picture. I don't have anything on my hypotenuse here, but I have a 35 here. Well, it's not going to do me any good unless I have something to pair it up with. So I'm just going to cross it out right now. That way I remember that it's extra information. It's nothing that I actually need. So for that similarity statement, I'm just going to say triangle XYZ is similar to triangle JKL. So XYZ, JKL went in the same order, so there's my similarity statement. There's the first part of the problem. And then the second part, where they want me to find each measure, whatever I'm missing, well, here's my X. So to set up my proportion, looks like I've got 13 to X. They're the same sides. And then 10 to 20, well, I know 10 over 20 is going to reduce to 1/2. So I'm just going to go ahead and reduce it right now. And then cross multiply and solve. Well, it's just X times 1 is still going to be X. 13 times 2 is 26. So that one was pretty simple. Didn't have to do a whole lot of extra work on that one. But that 35 was extra information. It wasn't anything that we needed, so that's why I crossed it out. Now, number 8, again, is another kind of a little bit tricky one. We do have a triangle and a triangle. The little triangle is GHW, and then our big triangle, GIU. So we kind of have to keep that straight. Now, this is where this one can be a little bit tricky. Remember, this whole side is part of the big triangle. So we've got 2 numbers there. So here in a second, we're going to have to use both of those, not just one or the other, when dealing with that whole triangle. Okay, so let's do our similarity statement real quick. So I'm going to say that triangle GHW, so that's the small one, is congruent to triangle, and now I need my big one, GIU. So there's that similarity statement. So then for setting up our proportion, well, we've got the base of the small is 20 and the base of the big is X. So I'm going to do that one as my first part, 20 to X. So then my sides. The side of the small triangle, just the small one, is 26. Okay, that's the side of my small triangle. The side of my big triangle is 26 plus 13. It's that whole thing. So that's actually going to be 39. So that's usually where we sometimes make a mistake. We forget to add them together. So make sure you do that. So 20 to X, small triangle to big triangle, and then 26 to 39. The small triangle is just the 26. Together we get that 39. 26 over 39, that's 2 over 3, so I'm going to reduce that just to make my math a little bit easier. So we get 2x equals 60 when we cross multiply, and then x equals 30 when we divide by 2. So a couple of tricky things that could pop up on your homework, so make sure you're just kind of watching out for those. Okay. Now let's go on and do number 9. Now number 9 actually has a little bit of a typo on it. This x should actually be on the line instead of clear out there, so you can move that. Now this one is actually a little bit nicer. It's a triangle and a triangle again, but they're telling you that 24 is the short, or the small triangle, and then 36 is the whole thing. So you don't actually have to add anything else together for this one. How they have it represented is a little bit easier. We do have a side that has a radical in it. That's okay. We can do our math with the radical. We don't need to change it to a decimal or anything. So for my similarity statement, let's go ahead, say triangle QSV is our large one. QSV is similar, and now my small one, triangle RST, there's my small triangle. So QSV is the big triangle, RST is the small one, so there's the similarity statement. And then for my proportions, to figure out my sides, to see if they, so I can solve for x. So small to big, there's that base kind of side again. We've got x to 36 root 2. So small to big, and then small we said was the 24, and big is that whole 36. So there's your proportion. 24 over 36 reduces to 2 over 3, so let's go ahead and reduce it just to make our numbers easier to work with. That leaves us with 3x when we cross multiply this way. Now the 2, remember you only multiply the 2 and the 36. The root doesn't change. So 36 times 2 is 72. And then the same thing goes for when we divide. When you divide by 3, you're only going to divide the 72 by 3. So 72 divided by 3 gives me 24. So we can leave the root 2 throughout our work and in our answer. We don't need decimals or anything. So a little bit different way of representing the problem compared to 8. So just make sure you kind of know the difference between the two of those. And then 10, now 10 is actually the trickiest in my opinion. Because those triangles are kind of nose to nose, you have to remember that one of the triangles actually got rotated around 90 degrees. And I know that's kind of hard to think about in our heads sometimes. But this triangle, let's say it was facing the other direction, I had to rotate it this way, so that way it's facing the bigger triangle. So when that rotation happens, you have to remember that now this side matches up here, and the x matches up to 38.6. So as soon as I do that, I realize, well, I don't have anything that matches the 23. That's extra information. So we have to remember that these two go together, and then obviously the 30 and the 60 are our two bases. So that's what's a little bit tricky about that one. You have to remember that it rotated. So for my similarity statement, we have our small and our big, but you have to be careful of what order you go in. So if I say A, B, C for my small one, so triangle ABC for my small one, then I actually have to start in this corner and do DBE for my large triangle. So have to be careful with the similarity statement, make sure you get them in the right order. And then again for our setup, now that we know which numbers have to go together, we get 30 to 60, small to big, and then x to 38.6. Now we do have a decimal in this one, so we'll probably have a decimal in our answer. That's alright, just solve it the way you normally do. 1/2, 30 over 60 reduces to 1/2. So when we cross multiply, we get 2x equals 38.6. Divide by 2, x equals 19.3. So again, you guys have seen a lot of problems on this practice, and not very many of them have been the same, so just make sure you really pay attention to the problems on your homework. That way you are solving them correctly, especially the ones that might be trying to trick you up. Okay, so a little bit of everything there. Now we're going to go on and we're going to do a couple of word problems. Let's be honest, they're pretty much the same as what you've been doing, maybe even a little bit easier. Word problems don't tend to throw in as many tricks as some of those other problems do. So it looks like on number 11, we've got 2 flagpoles. It gives us the height of one and the shadow that it casts, and we also have the shadow for the second one, but we need to find its height. Well, if you just kind of take away all the extra nonsense of the problem, you have 2 triangles just like what we've been doing for the whole lesson. So as far as setting up our proportion, we don't need to do a similarity statement or anything like that on this one. We can just go ahead and set it up. So 6 to x, I'm just going to call my question mark x, small to big. 1.5 to 7, small to big. Cross multiply, we get 1.5x equals 42. So then divide by 1.5, x equals 28. I'm just going to throw the label of feet on there since we are dealing with labels in this one. So still the same process, still the same setup you guys have been doing, just set up as a word problem. Now number 12, this is also another one that's talking about posts and their shadows, but there's no picture. I would definitely recommend drawing a picture, making sure you have everything in the right place before you start to solve. So it looks like we have 2 vertical posts, and one is 2 meters, and the other one is a little bit shorter, and it's 0.45 meters. So there's my vertical posts, and they cast shadows. So the shadow with the shorter post casts a shadow of 0.85 meters. And we are trying to find the shadow of the longer post. Okay, so there's my just rough sketch. Doesn't have to be anything fancy, just so you make sure you know where the numbers are. So I can go ahead and set up my proportion. So it looks like we've got 2 to 0.45. Big to small, and then x to 0.85, big to small. We can cross multiply. 0.45x equals, and you end up getting 1.7. And then when we divide by 0.45, we end up getting, I think you get 3.7 repeating. And it says, what is the length to the nearest hundredth? So we're going to just round that off to 3.78 meters. So same type of problem, same type of setup, but again, that sketch, that simple sketch that you do will probably be helpful in making sure you get all the numbers in the right spot. Okay? So that's pretty much our lesson for today. Like I said, there's not a whole lot of overlap on problems, so just make sure you're being very careful about which ones you're using to help you on your homework. The very last 2 problems are just simply review problems from 7-2, remembering what to do when you have x plus 1 or x plus 15. Remember, you're going to have a step of distributing before you can solve for your answer. So I'm not going to do those 2 with you, but you are certainly welcome to go and do those on your own. That way you are refreshed on what we did in lesson 7-2. I will give you the answers. You should get x is 15 and y is 27 for number 13. And then for 14, you'll get x is 9 and y is 27 again. So you guys can do those on your own, but I think you should be good to go. Again, if you have any questions or if you need help, make sure you come and see me.